right, we're back again, and in this video, we're going to do a review of functions. All right, so for anyone who hasn't seen math in a little while, I hope that this is helpful for you. So, in economics, in data analysis, the idea of functions will come up from time to time, and so I think it's valuable to kind of just get a quick refresher on functions again if you haven't seen math in a little while. Okay, so a function, which is often written like this, all right, or especially with an x in there, this is often kind of the notation. This notation would be said as function of x. So this is a function of x, all right. And what a function is it's somewhat of a black box. And so maybe I'll even just kind of draw this to kind of give an idea for it. All right. A function is something that takes an input, which I use the letter x to represent. It takes an input, all right, and it does something to that input to produce an output, which oftentimes we'll use the letter y to represent. All right. So a function takes an input and spits out an output. All right. That's a function. Now in math, what this typically means is that we will have a function. It takes an input x. The input always goes in there. There's the input. All right. And in math, what this looks like is it's some sort of mathematical expression that kind of explains or shows what is being done to the input. So we could have a simple example of 2 times x. This could be our function. Our function could be 2 times x. And so if we wanted to know what the output of the function was, we would just put in our input, multiply it by 2, and that would give us our output, or y. All right, so we can think about this. We can even kind of graph it. Let's say we had this function. So here's x, our input, and here's y, our output. If x was 0, so if the input was 0, the output would be 0 because 2 times 0 is 0. All right. If the input was 1, then the output would be 1, 2. So this would be the output, right? If the input was 2, then the output would be 3, 4. So the output would be 4, and so on. So this would be our function. It shows us, or it relates for us, how inputs x are related to outputs y. All right, so this is a function. We use functions all the time. Now, I just want to kind of highlight a couple of things about functions. All right, these are just, I think it's kind of a stylized representation. These just kind of a couple of quick points about functions that will probably be helpful. So one thing I'm going to say is that when we write functions, when we use this notation f of x, right, what goes inside of these parentheses, these are the inputs, right, as I said before. And what I'm going to do is I'm going to make a distinction between inputs that are variables and inputs that are parameters. This is somewhat of an arbitrary distinction, but I like to make it because I think it's helpful conceptually sometimes when we do certain problems. So let me kind of explain what I mean here. All right, before I explain this distinction, let me write out maybe a more complicated function, and I'll kind of explain once I've done that. So let's say we have a kind of a complicated function. Let's say we have a function 2x squared plus 5x minus 10. We could have a function like this. All right, you'll notice that this function is composed of uh, multiple terms, we'll say. Here, maybe I'll write it like this. This function has multiple terms. All right, this will become important when we do derivatives. It'll be important to distinguish separate terms in a function. All right, so this is kind of the first term, the second term, the third term of this function. All right, so you can have functions that are composed of parts, but it's all one function, right? All right, so just kind of make that distinction. Now, using this function as an illustration, I am going to explain what I mean by variables and parameters. Okay, so when I say a variable, what I mean is this is the components of a function that might vary in value. All right, so I'm going to use blue to represent variables. It's variables that typically go inside of these parentheses. And so here, oops, that should be black. Okay. The x is a variable. And so what I mean by that is x is a value that can vary. All right, so x can take on different values. You'll notice that the 2 and the 5 and the 10 and the 2 up here in the exponent, these don't change, but the x can change. And so I'm going to call the x a variable. All right, this will become very important when we do derivatives or calculus, because what we'll do is we'll use functions, and we will be very careful to understand how a function changes when the variable changes. Okay, so those are the variables. Now, what do I mean when I say parameters? Again, this is somewhat an interesting distinction, but I'm going to say all of these things that are not changing in the function, I'm going to call these parameters. So I'm going to just rewrite these in red to kind of use my color scheme here to illustrate what I mean. These are the parameters of the function. These don't change when the variable is changing. So the variable is something that changes, but the parameters don't change. Okay, so I like to make this distinction, even in cases, so we could have a case like this. We have a variable x, right? We could have a scenario where instead of the parameters being specified as particular numbers, that they're actually given as letters. So we could have a situation like this. Let's say B into my color combination here. Okay, so we could have this. All right, this would be a function where the x is the variable, it is varying, it is changing, and the parameters are all these other letters, and they're not changing. All right, so we'll call those the parameters of the function. Now, the surest way to know what is the variable will actually depend on the context. And so when we're doing derivatives, or when we're doing calculus, we'll always specify what the variable is, and everything else will be a parameter of that function. Now, sometimes if we want to be really clear, we might even write it like this. We might write, here's a function, here's the variable, and sometimes I'll use a semicolon, and then we can list out what the parameters are of that function. Sometimes you'll see it written like this, but not always. All right. Now, another thing that's important to notice about functions is that sometimes we can have a function that has multiple variables. So now I'm going to drop my color scheme here. We could have a function that has multiple variables. We could have 2x squared plus 5xz, let's see, minus 10z. We could have a function like this that has multiple variables. This can come up in some of the types of math problems that we will do in economics. All right, so you can have functions with multiple variables. You can have functions with variables and parameters. All right. Now, a lot of times when we work with functions, we will work with functions that might look a little bit more familiar to us, kind of like the example that I was just giving, with kind of multiplication and addition and subtraction and exponents, right? And we can work with those functions using the algebra tools that you would have reviewed in the algebra review video. But sometimes we have some kind of maybe more interesting or more maybe less common functions that will come up in economics or even in data analytics, and I just want to point them out. Actually, I want to point out one in particular because it comes up fairly often. So I want to talk about the natural log function. So that's what this NL stands for, natural log. So the natural log. Okay. I'm not actually going to explain what the natural log function is in essence. I could take the time, but I don't actually think that we need that for now. I think you'll want to know its practical applications, but that'll come up in the classes in which it's used. So suffice for now for me to just say there exists a function called the natural log. All right, and it's written like this. So ln of x is the natural log of x, and it's a particular function. And the reason I'm bringing it up is because it has some very unique properties that you should know. You should know how to work with the natural log function because it will come up and you'll want to kind of understand how to think about it. Okay, so I'll just kind of quickly review these and then we'll be done with functions. All right, so the natural log function has interesting characteristics. So let me show. All right, so we could have, let's say, the natural log of x times y. Imagine we had that. So here, this would be a function that has two variables, x and y. And so, and it equals the natural log of x times y. Interestingly enough, the natural log of x times y is actually equal to the natural log of x plus the natural log of y. Similarly, if we had the natural log of x divided by y, that's actually equal to the natural log of x minus the natural log of y. This is a surprisingly powerful and useful tool when working with functions, well, when working with the natural log function. All right, another example, and this will be the last one, is you can have the natural log of x raised to some power. Let's say the natural log of x raised to the 8th power. That's actually equal to a times the natural log of x. So this is a pretty neat function. It's a pretty cool function in the way that it kind of decompresses. It kind of, if you take the natural log of something pretty complicated, it can kind of disintegrate into smaller and more manageable pieces. So imagine we could even have something as complicated as this. You could have x to the a times y to the b divided by z to the c. Now that looks like a really messy equation. But what we can do is we can actually decompose it. I'll go through several steps here. Um, so this would be equal to this, natural log of z to the c power. All right, and I can decompose it further, natural log xa plus natural log of yb minus natural log of zc, and decompose it even further to a times, oops, do that from time to time, a times the natural log of x plus b times the natural log of y minus c times the natural log of z. All right, so it decomposes. And so here's something really messy, but it actually equals this much more reasonable um, equation there. Okay. Anyways, the quick review of functions, just a few little details there that I think will be valuable for you when you take, especially the economics course and maybe some data analysis courses. Okay. Thank you so much. Hope you have a great day.